Let's take a look at this example. I would convert first the voltage sources to the current sources. Okay, I have two voltage sources over here. See, this is the series circuit, voltage source and resistor. So this is voltage source and this is another voltage source. So I would convert both of them to the current sources. So let's find IS1. IS1 is equal VS1 over R1. VS1 is equal 900 millivolts divided by R1, which is equal 300 ohms. So IS1 is equal 3 milliamps. Okay, so I source 2 is equal V source 2 over R2. V source 2 is equal 2 volts over R2, which is equal 200 ohms. 2 volts divided by 200 ohms. So this is equal 10 milliamps. Okay, so let's say if you don't see that, you can always use the calculator. So for example, let me calculate IS2. So I have 2 divided by 200. This is equal 10 milliamps. Next, I have to redraw the circuit because my voltage source, okay, in this branch, my VS1 has the positive terminal at the top. So it means that my I source 1 will have the arrow pointing up. Because my voltage source 2 has the positive terminal pointing down, right? Going down to the ground. That's why my current source IS2 will point down. So let's draw it. Let's draw first current source. Okay, so I have my current source, okay, and I have my resistor R1. This is my I source 1. Okay, so I finished with this part. Next I have to talk about this one. So I have current which has to go down, and I have resistor R2. Okay, this is my ground, and I have my resistor RL over here. RL, and of course this is my voltmeter connected to terminals XY. Okay, this is my voltmeter over here. So what am I supposed to do first? Find I total. Okay, I'm going to consider this current as the positive and this one negative. So my I total is equal I source 1 minus I source 2. So this is equal 3 milliamps minus 10 milliamps. So I have I total is equal minus 7 milliamps. Okay, so this is my total current. Next I'm going to find the total resistance. R total is equal 1 over R1 plus 1 over R2 plus 1 over RL. Why? Because I have 3 resistors which are connected in parallel. So I'm going to write that R total is equal 1 divided by, open parenthesis, 1 over R1. So this is 300 ohms plus 1 divided by R2, 200 ohms, plus 1 divided by 600 ohms. This is equal 1 divided by, open parenthesis, 1 divided by 300 plus 1 divided by 200 plus 1 divided by 600. This is equal 100 ohms. Okay, this is my R total. So I can redraw the circuit, and my circuit is going to look like this. I have my I total, okay, and this is my R total over here. Okay, and these are the terminals XY. Okay, and because I have one current and one resistance, so I can find the voltage across this resistor. So VXY is equal I total times R total, where I total we found is equal minus 7 milliamps times R total, which is equal 100 ohms. So this is equal negative 700 millivolts. Okay, so this is my VXY. This is what my voltmeter is going to measure. So next I'm supposed to find IL. IL is equal VL over RL. Please keep in mind that VXY, the voltage between these 2 points, X and Y, is the same voltage which appears across resistor RL. That's why I'm going to use that voltage over here. So let's put VXY over RL, which is equal negative 700 millivolts over RL, which is equal 600 ohms. This is equal 700 negative exponent 3 negative divided by 600. This is equal negative 1.16 milliamps. Okay, so this is my IL. P total is equal VXY to the second power divided by R total. So VXY, we said this is equal negative 700 millivolts to the second power over R total, which is equal 100 ohms. So this is equal negative 700 exponent 3 negative to the second power divided by 100. This is equal 4.9 milliwatts. Okay, so we found VXY, we found VXY, we found IL, we found P total. Okay, so we can say that the problem is solved.